Alright class, welcome to learning outcome number 5. This is a PowerPoint presentation. We'll review and just make some comments. And we're going to think about representing problems in student work with appropriate equations, stacks, and strings. We're going to cite use of the properties in student thinking and strategies. So this will be a two-part lesson. We're going to start with part 1 today, and we'll finish part 2 on Wednesday of next week. So moving forward, we have a question about if this equation string is correct. Okay, is this correct? So this is an equation string example. And an equation string is where we have expressions here, 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 and here are all expressions. And they need to be all equal to the same value. Okay. So 126 divided by 7 should be equal to 18. So starting here should also be equal to 18. Now in the intermediary steps that we have, we've set 126 divided by 7 equal to 140 over 7 minus 14 over 7. Okay, and is that true? Well, that's a big step. What they've done between here, the first two steps, is that they've taken the 126 and broke it up into 140 subtract 14. And then we're going to keep the divide 7 in, and then that's the same thing as 126. Divide that by 7 as well. And when we do that, we are taking the one, we can use back distribution from division over subtraction. And we have 140 divided by 7 subtract 14 divided by 7. Okay, and those were strategically calculated so that they can have nice divisions. And that's why 140 over 7 becomes 20, and 14 over 7 becomes 2. And then 20 minus 2 is equal to 18. Okay, so all of those are equal in value. So yes, that is a valid equation string. Okay, so somebody had thought about how to divide 126 by 7 in a creative way, and students will come up with creative ways to do math. And what skill that you will need to learn from this course, that you will gain from this course, or this learning outcome, is to track that thinking on like a whiteboard or some overhead projector or something, so that all the other students can see their thinking and see that it's valid mathematically. Okay. Here's another equation string. Is this correct? 7 plus 8 divided by 5 times 3 plus 6. Okay, lots of stuff right here. Is that the same as 15 divided by 5? Is that the same as 3 times 3? Is that the same as 9 times 6? Is that the same as 15? 9 plus 6, sorry, and that's the same as 15. All parts, all expressions in between all the equal signs must be equal in value. That's what we learned so far in this class, is that they need to be all the same as. And when we have 7 plus 8 divided by 5 times 3 plus 6, all that this part is right here is this part right here. 7 plus 8 being 15, and then the 15 divided by 5. There is more going on here than is included in this side, in this part of the equation. And so therefore these are not equal in value. We can tell that right up front for just the first two parts of the equation string. Okay, 15 divided by 5 is equal to 3, but 3 times 3 is equal to 9. 9 plus 6 is equal to 15. That is true right here, but this is not true, this is not true, and this right here is probably going to end up being 15 anyway, and that's not equal to 3. Okay, so because there's so many parts that are not equal, we can say that this is not a valid equation string, invalid equation string. Not all the parts are the same. Okay. Let's see how this equation string can become a valid one using this approach. So using equation string here, what we have is 7 plus 8 divided by 5 times 3 equal plus 6. Now the 7 plus 8 became 15 in this next one. Okay. And then 15 divided by 5 became 3 in this next one. Okay, so 15 divided by 5 became 3. 7 plus 8 became 15. Okay, everything else is carried through to maintain equality. We have times 3 plus 6 times 3 plus 6. Now 3 times 3 is 9, so we become that. The 3 times 3 becomes 9, and then the 6 is carried through. 9 plus 6 is 15 at the end. That's a valid equation string. If you're doing one operation to at a time to the expressions in between the equal signs and carrying everything else through, that will maintain equality. Now equation stack is another term for this lesson, and the equation stack is just a stack of equations. Now they are not all saying that, we're not all saying that this expression right here is equal to this one. We're not saying that, okay? We just are going to say, okay, this is what this first step is. This is what the second step is. This is what the third step is. This is what the fourth step is. Okay? As we do each of these equations, we stack them all together. And so we have our set of equations. So what we do is we end up with our answer. And so this is valid equation stacks, just a series of one operation on two numbers at a time. Well, let's take a look at the equation stack and equation string. Can you think of any benefits to seeing the mathematics done a certain way? They are the same steps, they are the same beginning problem, and they are the same answer. Okay. Go ahead and pause the video, think of a few things in your mind, and then we can resume. Okay, so thinking about these, notice that this one right here is more compact and this one is really long. So that's probably a difference there, benefit of the equation stack. The equation string can show as a benefit there, can show the quality of all of the mathematical operations and ideas. Okay, so that has a valid point there. Another way to view an equation string is to write a little bit like the equation stack, but notice that we'll keep all of the things equal. If we start by saying that 7 plus 8 divided by 5 times 3 plus 6, if we write the next part right here under here, and then this part right here under that, this part right here under that, and this part right here under that, right here under that, it will also become a string, but look more stack-like. But notice that the stack is not putting equal signs in front of everything. So a lot of people do their equations stacks and thinking like this, where we put this one under here, and then that's going to equal 15 divided by 5 is 3, times 3 plus 6, and that's 9 plus 6, and that's 15. So this part right here came right here, this part right here came right here, this part right here is right here. So that's a more compact way of doing equation string, and even though they're kind of stacked up there, but it's not technically the equation stack because we are keeping everything equal. Here we're just doing one operation at a time, 1, 1, 1, 1, by just two numbers. Here we still have all the numbers, and then one last number. Okay, so I will probably write equation strings vertically more than horizontally. So they can be written vertically or horizontally, as in the slides and in the reading. Okay. Here's a email that Dr. Walters got from a student. It says, the run-on math sentence. Dr. Walters, I was just looking over notes from class today and I noticed that I wrote an equation this way, where I did 2250 divided by 477 equals 4.8. And then the student continued to operate on the numbers. Okay. the student continued to operate on the number, where they're doing more mathematics. And they just kept multiplying or whatever and setting things equal after that, getting your answer after that. More of the operational view of the equal sign. Notice operational view, because this part right here is equal to this one only. And now the operational view can be incorrect, lead to incorrect thinking, because you're multiplying by 204. Sorry about that. And 2250 divided by 477 is not equal to 4.8 times 204, but just 4.8. Okay, and 2250 over 477 is definitely not equal to this part of the expression over here. Not equal. Okay, that 962.26. So the student continues by saying, with my new handy-dandy understanding of the equal sign, I realized that this was wrong. Kind of like math version of a run-on sentence. Is this the correct way to record my steps? To just put a new line instead of inserting an equals? Okay. What the student did was demonstrate an equation stack. So yes, that is a good way to show your thinking. Okay, so it's kind of neat that the student actually was thinking about these types of things outside of class. Okay, number talk equations. Now, we're going to use the equation. In elementary school, you will do number talks in mathematics, and so they're really kind of fun. And as you will see in these videos, we want to have number talks just like these teachers do. Okay, we'll use equation stacks and equation strings to record student thinking. A student says, I did this first, and then this next, and then this after that. We need to record every step as with the class, so they can see it on the whiteboard or whatever projector you're using, smartboard or something. And you can compare the methods of each student after several students have contributed. Okay, so here is where we're going to end our PowerPoint for today. And I want you guys to watch these two videos and try out the equation stacks and strings. Okay, so then after that's a homework. Okay, so try out the equation stacks and strings to write them all down. So let's go ahead and see what other directions we got here. So I can give you some more. Make sure I got them all. Okay. So you want to take down students' work or take down the teacher's interpretation of students' work in the forms of equation stacks and strings. We can transpose the equation stacks into strings and vice versa. And so that's kind of how we'll go. So next class, for next Wednesday, we'll talk about number talks and what equations, stacks, and strings can be modeled from number talks. Okay, so go ahead and watch these videos and give it a try.